In section 6, we're going to cover range, mean, and median. Before we do much with these, we have to make sure we're familiar with the terms and how to actually find each of these. So the range is defined as your high value minus your low value. So looking at our data here, we have 15, 15, 33, 29, 23. 33 is our high value, and our low value is 15. When we subtract those, we get 18. So that would be our range. Our mean is the average of them. So to find the average, we're going to add up all the points. 15 plus 33 plus 29 plus 23. And that total that we get, which is 115, we're going to divide that by how many entries we have, which is 5. That would give us a mean of 23. To calculate the median, we're looking for the middle number in the ordered list. So in other words, we have to put the data points here in order. So 15, 15, 23, 29, 33. The median is the middle number. So I'm going to start crossing off numbers at the top and the bottom and settle on one number in the middle, which would be our median. The second set of data is really the same thing. So again, to find the range, we're doing high minus low. Mean is just add them all up, divide by 4 in this case. What gets a little bit tricky is when we do the median, these are already in order, so that's nice. When I cross them off, I'm left with these two numbers here. So when I have that situation where I've got two numbers in the middle, to find the median, I'm going to add them up and divide by 2. And we end up getting 61.5. All right. In activity 1, we're going to start by looking at a scatter plot of the number of pounds of newspaper that a recycling club has recycled per month for 10 months. We don't have data for month 11 or 12. Question 1 says, what's the total number of months for which more than 500 pounds of newspaper was recycled per month? What I'm going to start with is on this graph, I'll zoom in a little bit so we can see it better. I'm going to go to 500, and I'm just going to draw a line across it. And anything that's above that, I'm going to count. So I've got 1, 2, 3, 4, 5 months where we have recycled more than 500 pounds. What is the range of the numbers of pounds of newspaper recycled per month for 10 months? So again, range is the high value minus the low value. This is our high output of 800, and this is our low output of 200. So to find the range, I'm going to take 800 minus 200, which gives me 600. My explanation is the work that I've done. 3 says, what's the median number of pounds? The median is the middle. So to do this, we're going to start crossing off data points from the top and the bottom. Again, we're looking vertically, not horizontally. So we want to know, what's our high point? Well, it's 800, and our low point is 200, so we get rid of those. We look at the next highest value, which is 700, and the next lowest. Next highest is 700 again, and our next lowest. Next highest is 600, and we cross off 400. So we're left with these two right here. Again, like we did in the warm-up, when we have 2 points in the middle, we have to average those out. So I'm going to take 600 plus 450 and average those. That gives me 1050 divided by 2, which is 525. But this next one is kind of the same thing. We're going to kind of go quickly over it. Not going to do quite do the answers for it. But range, again, we're looking for the high value minus the low value. So we're looking at a table of values here. The mean, we're going to average or add up all our values, average them out. We should be good to go. And then for attendance, the median attendance, we're looking for the number in the middle. And one strategy is we just start crossing off low and high. Let's see, those. And then our median would be those numbers there. We average those out. This is what's called a line plot, and this plot is going to show the number of skateboarders who own a particular number of skateboards. Each of those X's represents a skateboarder and how many skateboards they own. The range of numbers, again, just like we did before, we're looking for the high value minus the low value. So 5 minus 1 is 4. The mean is all of this added up, divided by, it looks like we have 10 members. So we're going to take 1 plus, and I'm going to count this 2 4 times, so that's 8. I'm going to count 3 3 times, so that's a plus 9, plus 4, plus 5, and again that's divided by 10. So I've got 9, 18, 22, 27 divided by 10, which is 2.7. Now, it's not specific on how we want to round, so 2.7, we can round it to 3, we can leave it at 2.7. Preference would be to just leave it at 2.7. The median number, we're going to cross off. Actually, I'm going to highlight these, because crossing off an X is probably not a good idea. So I'm going to highlight those top and bottom. And the top and the bottom. There we go. Alright, top and bottom. What we're left with is a 2 and a 3. So when I average those out, that's going to give me 2.5. That one I definitely don't want to round, because if I rounded it, that would indicate there was actually 3, and that was the median point. It's actually not. It's between 2 and 3. I like this particular question because it's really going to test our knowledge of what these quantities are. There's 20 students in Mrs. Watson's math class. She's going to divide her class into 2 equal groups by the distance they live from school. All right, no 2 students live the same distance from school. Which measure of this data will divide her class into 2 equal groups of 10? The range will tell us how far apart they are as far as their distances go. That's not going to divide them up evenly necessarily. The mean is going to tell us the average distance away. I don't know that that's going to help us divide it evenly out. However, the median definitely will, because the median, I should probably capitalize median here. All right, let's do that again. Median, because it divides data into 2 equal halves. So half the data is going to be above the median, half the data is going to be below the median. That's what it does. So this will definitely divide those 2 groups up. In activity 2, we're looking at what's called a frequency table. Now this gets a little bit trickier because a lot of different things we need to keep in mind. We have some data here that we've gathered from a stem and leaf plot. It is the distance that math teachers drive to school each day. So a 0, 5 is represented by 5, a 1, 0 is 10, and so on. So from the stem and leaf plot, it's fairly easy, I think, to find the range. We're just going to take our high value, which is 60, minus our low value, which is 5, and we end up getting 55. To find the median, we're looking for the middle number, so we're essentially going to just start crossing some things off until we get to our middle. Which will be 20. And for the mean, we can add them all up and divide by 15. And we're going to save that for a minute. You'll see why when we get to the frequency table. But this same data can be represented down here by a frequency table. And the frequency table tells us how often something occurs. We can tell that from the stem and leaf plot, but this makes it a little bit easier to see that frequency. So to work with a problem like this, what we're going to try and do is the same calculations using just this table. So our range, it's really no different from what we did before. We're looking for the high value, which is 60, minus our low value. Now, these numbers over here do not represent the data, just how often it occurs. So our answers are going to be something in terms of minutes. So we should have answers between 5 and 60 minutes, because that's our low point and our high point. So the range we calculate the same way we did stem and leaf plot, high minus low, it's 55. To calculate the mean, it's a little bit more complicated. Instead of just adding every single number up, what we can do is basically do that, or we can do a little bit quicker. So what I like to do with these problems is I like to take the column on the left and the column on the right and just multiply those numbers. So 5 one teacher at 5 minutes is 5 minutes total of travel time. 4 teachers at 10 minutes is 40. 1 at 12. 1 at 15. 2 at 20. 1 at 25. 2 at 30, that's 60. 2 at 40, that's 80. And then 1 at 60. And then we can go ahead and add those numbers up. So let's see, 5 plus 40 plus 12 and 15 and 40, 25, 60, 80, and 60. And I end up getting, what do I get here? 301. Something's off. Oh, there we go. So let's try that again. I made a little mistake here. Instead of the 4, I have 40. So because I know that I missed by 36, I'm going to add 36 to that. That's going to give me 337. So that's my total here for the minutes traveled. I know there's 15 teachers because it tells me up here, but I can also count the number of teachers here to give me 15. So to find the mean, I would take 337 and I would divide it by 15. And when I do that, I end up getting we'll call it 22.5. Again, that data does fit between that 5-minute window and that 60-minute window, so we're good to go. Now, the median's a little bit more challenging, and the median involves a little bit of kind of circular logic here. If we have 15 teachers, the median divides it into 2 equal pieces. If I take 15 divided by 2, I get 7.5. What that means then is that I have essentially 7.5 numbers on the left, 7.5 numbers on the right. I can't really divide a number into 2 pieces. What I'm looking for then is so that I have a 7 on the left and a 7 on the right of the data. I'm looking for the 8th entry. So to find the 8th entry, I'm going to start at either end, either the 5 or the 60. I'm just going to start counting until I get to the 8th person. So I have 1 person, another 4 makes 5, 6, 7, and my 8th and 9th person are here. So the median is going to occur there, and the median value then would be 20. We get the same answers with the frequency table as we did with the stem and leaf plot. Just a different look. So similarly, again, the whole point of this is we want to make sure that our answers, we're talking about number of books, the number of books, falls somewhere in here in the 5 to 9. If they don't, we're going to run into an issue. So our range, we can just subtract the high minus low. For the mean, we're going to multiply all these things together. So 5 times 105, 6 times 84, and so on. And we'll add all those up and divide by the number of books, or I'm sorry, the number of students that we have. And that would tell us how many books each student has. So in the next part, we're going to take a look at what happens when we add data that wasn't there before. What does that do to the mean, the median,